Hi, in this video, we are going to see the introduction of a hybrid electric vehicle. On the screen, you are looking various type of EV manufacturers. Some major manufacturers like Mahindra, Maruti Suzuki, Tata Motors, Hero Electric, and etc. These companies are mainly involved in manufacturing the passenger cars. They also now manufactures various cars, vans, e-bikes, e-rickshaws, that is two-wheeler, three-wheeler, and four-wheeler. Nowadays, they are also involving some their projects to manufacture the heavy-duty vehicles like trucks. Okay, now there are some basic terminologies in EV segment. So, electric vehicle is a vehicle which run on the electricity only. After that, the hybrid electric vehicle, that is HEV, which run on the electricity as well as another plus one source, which may be the fuel. After that, a plug-in hybrid electric vehicle, that is the PHEV, which works on the electricity. You have to plug in and charge the vehicle, and then it can run. After that, last one is the fuel cell vehicle, that is EFCV, which use the hydrogen as an fuel, and then it will work on it. Okay, so let us see one by one in details. So EV, the battery must be charged from the external source and some energy recovered from the regenerative braking through the motor and generator. In the screen you can able to see the constructive diagram of the electric vehicle. Now the hybrid electric vehicle, that is the HEV, energy source is hydrocarbon fuel, batteries are used to store the energy from regenerative braking. Okay, so in this case, you can able to use the two different sources as an energy or as an fuel. Okay, so this is the basic fundamental structure of HEV. So it requires some batteries as well as IC engine to propel the rotating parts. This is the PHEV plug-in hybrid electric vehicle. The energy sources are hydrocarbon fuels and grid electricity. Now fuel cell vehicles, that is the FCV. Energy sources is from the fuel, that is the H2 from the source, and some renewable. Batteries are used to store the energy and recover the regenerative braking. Now in this type energy source, hydrogen and oxygens are used, and due to their reaction they produce the electricity and it will be stored in the batteries, and on this charge this kind of vehicles run. Now actually what is regenerative braking? It is nothing but while applying the braking or at the time of reducing the speed of the vehicle, it produces some electricity, and this electricity is transferred back to the source or storage unit. On the screen, you are able to see the conventional vehicle's drivetrain, which includes the engine, clutch, transmission, U joint with a drive shaft, and wheels with differentials. Now, this slide is of the IC engine characteristics. So, IC engine or the conventional vehicle which use the gasoline as a if use a source or the fuel. In the figure shows the characteristic for the torque power with the specific fuel consumption, as well as on the right hand side if the vehicle is on the fuel of diesel, then this will also show the torques and its power characteristic with respect to specific fuel consumption. So on this characteristic or by using these characteristics, we are able to conclude or calculate the information related to the torque, power, and fuel consumption. From this graph, we are able to understand that it simply in the gasoline vehicles, the torque will reduce sharply at the maximum speed, but in case of the diesel vehicles, torque reduces slightly with respect to increase in the speed of the vehicle. Okay, that is why in case of the or in the most of heavy duty vehicles, they are work on the diesel. Now these are some comments. After seeing the characteristics, you can pause the video and watch it, read it. This is an constant power curve, which shows that as road speed falls, the tractive effort increases in the proportion to the increased resistance, and thereby providing the very stable condition. Now this curve shows the resistance offered in Newton to the vehicle with respect to the speed in kilometer per hour. So there are various situations or the point or interval of a specific speed at which offered resistance has been shown by the point the PQRS. Here the graph or curve of P shows the gradual resistance or the opposition offered to the vehicle. Okay, so in on right hand side is also the total resistance in Newton with speed in kilometer per hour, that is the graph or curve ABC is shown with various situations. This graph shows the performance curve with the scarce speed in the kilometer per hour versus the total resistance and the tractive effort in Newton with respect to the car in the various situations. Now let us see the engine torque curve. So this torque curve shows the speed with respect to the torque graph of A, B, C, D. Now, if the vehicle loses its speed from point A to due to the increase in the road resistance, at this situation, the speed of the RPM or speed of the engine will reduce or fall. But at this situation, torque will be increased and it will try to restore the uniform road speed without changing the gear. Okay, so this is the first understanding. Now if the point is C or D of the curve applied in a slight increase in the resistance will introduce the unstable situation, and at this situation some torque will be false and it would be necessity the increase in the resistance. It would also helps or the slight increase in the resistance introduce the unstable situations which falls causes falls the torque, and it will be a rapid change down to a lower ratio to improve the torque of the machine. Okay, now this is the constant power curve. It give or represent the constant power output at the various situation in case of the speed and the tractive effort or tractive power requirement. On the screen, a figure shows the primary EV or basic EV powertrain, which includes the electric energy storage system, that is the battery system or battery management system, which gives the electricity to the electric motor drive, which convert the electrical power into the mechanical power, and it will be transmitted toward the mechanical transmission system. It will again with the help of the gear arrangement propel the machines or propel the wheels of the EV. So this is the basic structure of the primary EV powertrain. By the electric section, we can see that the basic powertrain includes the battery charger, high voltage battery system. Again, this sectionalized in two parts, that is the DC to DC converter, ancillary loads like lamp, wipers, or power windows, etc. So main power is again transferred to the bidirectional converter or inverter section. It gives the electricity to the electric motor, and on the basis of this electric motor, drive the wheels of EV. Okay. This figure shows the illustration of the general EV configuration. So there are some symbols for the brakes accelerators. Here on the downside of this block diagram, double line means that the mechanical link. The dark arrow shows the electrical link, and a single line arrow shows the control link. That link means that this gives some signals or feedback communication system which control the various operations in the EV. So by pausing the video, you can able to see the various blocks which are mainly included in the general configuration of EV or major parts of the EV. So some of them already we have discussed, like vehicle controllers, electronic power converters, electric motors, mechanical transmission with respect to wheels. So this is the general EV configuration, but this is controlled by some other blocks like energy source system and auxiliary subsystems, which include the energy management unit, energy source, and energy refueling unit, which take the power from external source. These energy source provide the electricity to the electric vehicle motors, as well as some miscellaneous equipments like power steerings and other climate control units and other like power windows, etc. This slide shows the possible EV configuration. This is the pure EV vehicle, and with the arrangement of clutch differentials, fixed gearings, and motor systems. You can able to connect these parts like a machine, fixed gearing, differentials in the various manners, and by the manner of connection, we can construct the various configuration. Okay. This is the motor efficiency characteristic. That means that in the EV, motor is the main part. So we have to concentrate on the motor performance. So if we want to run a motor in the EV at its maximum efficiency level, then we have to refer this chart. So with respect to the motor speed and motor torque, on the basis of their configurations, we can able to use motor more efficiently. That means shortly, we can able to go long in the single charge. So this graph shows this percentage wise, that is the 90%, 88, 86, 83, 80, 78, 70, and 60%. That is, this covers some area of torque and speed, which shows the maximum efficiency level. Here are some requirements of EV motors. So rigidness is the first and most important requirement. Second one is that the high torque to inertia ratio. Inertia means the weight of internal parts. After that, the peak torque capability of about 200 to 300 of percent of the continuous torque rating. After that, the high power to weight ratio. That means in the less weight of machine, it can able to produce the high power. After that, the high speed operation and ease of control. That means we should be able to control the speed of machine or control the machine easily. After that, the low acoustic noise, low electromagnetic interference, low maintenance, and low cost, as well as the extended constant power region of the operation. So these are some technical requirement of the EV motors. These are some motors which are commonly used for the EV. So first one is that the S induction motor, after a synchronous motor, SRM, that is the switch reluctance motor. After that, permanent magnet DC motor, which is also known as the PMDC or PMAC motors, and our last one is that the brushless DC motors. Now let us see one by one. For more information, please stop the video and watch the information carefully. While selecting the battery, we have to consider following points. Now, what is the specific power? That is a indicator of maximum power that the battery can deliver instantaneously. What is specific energy? The energy capacity per unit weight of the battery. Now, what is the energy density? How much energy per unit volume of the battery can store? And what is the life cycle? The life cycle is nothing but the measured in number of cycles, means how many times it can able to charge and discharge. Similarly, other points are the high efficiency, longer cycle time, reasonable recharge time, recyclable material, low cost, safety, reliability, and low maintenance. These are some important points. So these are some additional and also important performance measures or parameters of the battery. First parameter, charging and discharging curve. Second parameter, self discharge. Third parameter, internal impedance. Fourth parameter, depth of discharge. Fifth parameter, cycle life or life cycle. And last parameter, temperature characteristics. And all these characteristics are controlled and operated and sensed by the SOC, that is the state of charge, and BMS, that is the battery management system. Now here are various type of batteries or the battery technologies, that is the lead acid battery, nickel cadmium battery, nickel metal hydride battery, lithium ion battery, and lithium polymer battery. So you can able to read on the screen, that is the energy density, power density, and the range of each. Now these are some important battery parameters on which we can able to detect the capabilities and some performance of the battery. So first one is that the state of charge, that is the SOC. Second one, DOD, that is the depth of discharge. Third one, C rate of the battery, that is the charging rate. And last one is the SOH, that is the state of health. Now to clear the concept, you can read the information of the SOC and DOD. To read the information clearly, please pause the video and also try to play the video in 720 pixel and above frame rate. Now this is the battery management system. It works to increase the life of battery system, and it helps to improve the efficiency of battery system, which include the balancing of cells, voltage control, current control, thermal control properties, as well as the isolation of fault or the faulty parts, as well as the thermal management and the power management. These are the types of the power converters, which are mainly classified in two types, that is the AC-DC converters and DC converters. So AC-DC converters are being isolated, non-isolated type, and similarly DC-DC converters are of the isolated, non-isolated type. So various type of chargers are there with the type of or the range of various voltages, rating of current, and the charging load. Okay, so please read the information of their specification and details with the various international codes. Here are some limitations of battery based electric vehicles. First and most important limitation, that is the high initial cost, many times that of the conventional vehicles. So second one is that the short driving range. So less miles during each recharge. You have to recharge time to time at a shorter distance to your electric vehicles. So that is why people needs a vehicle not only for the commuting, that is the city driving, but also for the pleasure, long distance highway or a long drive in short. So next limitation is that the recharging take much longer time than the refilling the gasolines or other fuel injection. After that, last one is the battery pack takes space and weight of the vehicle, which otherwise is available to the user. All the EVs has a less maintenance than the conventional vehicle because there are various causes like battery, motor, and associated electronics require little to no regular maintenance, as well as there are fewer fluids or oils, engine oils, and so they required less maintenance. Brake wearing is less due to the regenerative braking. So we have already seen what is actually regenerative braking, and there are fewer moving parts. Okay, as with respect to the conventional fuel engines. This slide shows the interdisciplinary nature of EV. So various blocks or sections are there, and various topics are there. Let us see. What are they? Energy storage, vehicle design, vehicle modeling simulation, regenerative braking, control and power management, emerging technologies, power electronics and electric machines, vehicle dynamics, etc. In short, we can say that while building or manufacturing EV, we have to go through these various broad topics. These are some government policies, initiatives for EVs. Under this initiative, government gives some subsidies to the manufacturers or users. The first is the NEMMP 2020, that is the National Electricity Mobility Mission Plan. Second one is the FAME, that is the faster adoption and manufacturing of electric vehicles. Now, FAME 2 policy is implementing, and before that, FAME 1 policy was implemented. Here are some research challenges for the EV. First one is the range improvement strategies. Second one, battery thermal management. Third, regenerative braking. Fourth, lightweighting. Fifth, electric motion and control. And last, operational control strategy. So these are some areas in which we can able to do some research and some innovations. By doing this, we can able to modify, improve our EV technology.